Hey, how's it going, everyone? It's Lee Halliday. I saw this tweet the other day from Ken Wheeler, and he said, other times I'll ask more general questions like hand implement a reduce. So I was thinking about how much I love the reduce function, how versatile it is, and just in case you're getting interviewed by Ken Wheeler, you'll know this thing rock solid. What we're going to do today is look at 10 examples of how to use reduce, and then we're going to implement a simple version of reduce ourselves. So to get started, we'll open up VS Code, and I've got some data here. It's just an array of 3 people, me and my 2 sisters. And what we're going to do is implement a whole different number of ways you can use reduce. It may not always be the most efficient way. If there's a sort of native function in JavaScript that does it, you should probably just use that instead. But it's a good way to sort of understand and get comfortable using reduce. And I'll explain sort of how it looks and how it works in a second as we get into it. So the first thing we're going to do is we're going to use reduce to count the number of people in this array. You could just say like people.length, right? But we're talking about reduce, so let's do that. We're going to save our result in a variable I defined here called result. So result is people.reduce. So reduce is a function you always call on arrays. And you pass a callback function and an initial value. So we're counting, so let's start at 0 as our initial value. So our callback will always receive an accumulator, so some number that's being passed from one call of this callback function to the next, plus each element as it's iterating over the people. So we'll call this person. So what are we trying to do here? We're trying to count. So what we'll do in this case is in sort of arrow function, we'll just take the current accumulator or the sum and we'll add 1 to it. So we'll start at 0. 0 plus 1 will return 1. Next time it gets called for a person, we'll return 1 plus 1 is 2, etc. So if I run this, we'll do node index like that, and it gives us 3. So we're finding the correct result. So let's make it a little bit harder. Let's try to find the sum of all the ages. So these ages here. So people.reduce, same setup, a callback function that's called once for each iteration over all the people. An initial value, so we'll start it at 0 again. We've got our accumulator and our person. So what we can do is return our current accumulator, the sum, plus the person.age. So rather than just returning 1 each time, we can access a value from the person. So if I were to run this, 93. So my family, my siblings, we add up to 93 years old. So you don't just have to count things or sum things. You can start with any sort of initial value. What we're going to do now is cover basically how to use reduce as if you were mapping. So we'll say result is people.reduce, callback function, initial value, we'll start it as an empty array this time. So we're past our accumulator, which is this array as we're iterating over the people and the person. So I said here we want to return an array of names. So what we can do is we can return a new array, which is all of the previous names plus the new name. We'll tack that on to the end. So run this. Now we have just converted from an array of objects to an array of names, which is exactly what map does, but we implemented it using reduce. This is an example is probably just use map. I mean, it's way easier, right? But it's good to know how reduce works. Next, and this is something I do all the time. Say you want to have you want to find, in this case, you want to find a person by their ID. Now you could iterate through the array every time you want to find someone, but that would be very slow if you had 10,000 people to look through. So what I sometimes do is I basically convert this style of array to a dictionary where the ID is the key and then the object is the value, so that anytime you want to access a person, you can just access them using the ID rather than having to find them in an array, and it is a lot more efficient. I'll show you what I mean in a sec. So same thing, reduce our people. We've got our callback function. We've got our initial value. This time will be an object. And we've got our accumulator, and we've got our person. So what we are going to do is we're going to produce a new object. So why don't I just do this the extended format this time. So we'll return a new object, which will be anything we had before, so spread it out. Plus, we want to have, imagine we've got person 3. We want to basically have 3 plus that person, sort of like that. What we can do to do this dynamically is we can say person.id, that's the key, and the value will be the person, just like that. So if we run this, what we end up with is an object or a dictionary or a lookup table or something like that, where we've got the key being the person's ID and then its value. Now, for example, if you wanted to find someone, all you'd have to do is say console.log result. Let's find person 3, like that. What did I do? Oh, there we go. It's that one right here. So we found Heather just by looking her up using her ID. So that is a lot more efficient than looping through the array every time you wanted to find someone. Cool. You can use reduce to find the max value. So I'll show you how that would work. So we'll do people.reduce. And here again, you'd probably, I guess you couldn't use math.max. You'd have to first map the array to just get numbers and then find the max of those. So in this case, it's probably more efficient to use reduce. But we've got our callback function. We've got our initial value. I'm going to just start it as null here. And because I don't want to start as 0 because 0, if they're all negative values, 0 would come out as the max value, and that doesn't make sense. So let's start it as null. We've got our accumulator and our person, and we'll put a bit of logic in. So if the accumulator is currently null, or the accumulator is, or the person dot age is greater than our current max number, what we'll do is we'll return the person.age. So the next iteration, the accumulator will come in as whatever age we've returned. So in this case, we're hoping for 35 to come out as our result. Cool. If that's not true, what we'll do is we'll just return the current accumulator. So whatever the current max value is. So we run that, we find 35. If we wanted bonus, we'll do 11. So let's say we'll find the min age. So in this, what we'll do is we'll swap that. I think that's all we have to do. And there we go. We just found the min age. So just to go over it again, if we haven't even set a value yet, or the age of the person we're currently on is less than the lowest age we've found so far, set that, return that as your new accumulator value as you're iterating over. Okay, let's try to write a reduce function that will find a person by their name. So what we'll do is we'll say we're going to reduce the people, callback function, let's say null as our initial value, and we've got our accumulator and our person. So you're getting the pattern over and over again. So this logic's a little bit weird, and in this case I would probably use the people.find function because A, it's going to be a lot more efficient and a heck of a lot less confusing. But this is just to prove that you can do crazy stuff with reduce. So what we'll do is we'll say if ACK is not equal to null, that means we've already found someone. So we're just going to return that person, basically skip iterating over the rest of the people. We've already found them. Here's why it's not efficient, because we found the person as the first item in the array. It's going to have to keep looping over the rest of them. So don't use this method, but that's fine. So if we get to the second if statement, it means we haven't found the right person yet. So what we're going to do, let's just say we're looking for a person with the name of Lee. So if that matches, what we'll do is we'll return that person. If we haven't found the person yet, we will return null, meaning it will just keep looking. So let's run that. And there we go. We found my person in the array. Moving on to the next one. Let's see if all the people in the array are over 18 years old. So people.reduce, callback function. Let's start it out as true. I may be wrong. We'll see. Let's see. Think about that. We want to assume they all are, unless we find one that isn't, in which case we'll flip it over to false. So we're going to start assuming it's true. I don't know. We'll see. So we've got our accumulator and our person. So what we'll do is we'll say if it's already been flipped over to false, meaning we've already found someone, let's just return false, because it's still false. As soon as one person is not over 18, that means they're not all over 18. Otherwise, we will return whether the person.age is over 18. So run that. It's true. So if we were to change this to say if they're all over, let's say 30, false, because there's one person that's not over 30. Okay. Next, we're going to see if any are over 18. So we don't care if they all are, but is one person over 18? I think this is also called sum, the function in JavaScript. And again, if there's a native function, use that instead. But just to show how it works. So people.reduce, we have our callback. This time we're going to start as false. But as soon as we find someone, we're going to flip the switch and make it true. So we've got our accumulator and our person. So what we're going to do is we're going to say if this accumulator is true, it's true forever. Otherwise, we're going to return person.age is over 18. So we run this, it's true. If we set it to 30, it should still be true because I'm over 30 years old. If we set it to 40, it should be false because nobody's over. Perfect. So it seems to be working. All right, we're going to switch up our data a little bit, and we're going to see how can we count occurrences of some value in an array. So here I've got an array of orders, just with a random ID and a status. So I want to count how many times each status shows up, and I want to end up with an object where you've got the status and how many times it occurred. So we're going to say result equals orders.reduce, but same idea, and we are going to start it off as an empty object. So we receive our accumulator and our order, and what we are going to do is return. And what we're going to do is we're going to take all of the counts we've found so far, and we are going to update the current status that we're looking at. So we'll do this dynamic key setting again. So this would be order.status, and its value is going to be whatever it was before plus 1. Now, if it's the first time we see this thing, it's going to be whatever it is. I think it's undefined if that value is not there. So what we're going to do is we are going to look it up and see if we have this status yet. So ack@order.status, or so if there's a value for this, we'll get that value, whether it be 2 or 5 or whatever. Or we're going to start it off at 0, meaning we're initializing it, plus 1, just like that. So take all of our accounts so far. We're going to update the current status that we're looking at, whether it be pending or canceled. We're going to take the existing value or initialize it to 0, plus 1. Bit of a mouthful, but there we go. So there's 2 pending, there's 1 canceled, and there's 1 shipped. All right, the next one we are going to look at is how to flatten an array. So this is often it's when you've got nested data structures. Like imagine a folder that can either have a file or another folder that contains other files. Maybe there's a folder that contains 1 file plus another folder with 2 files. And you want to end up with an array of just file names. So you want to flatten that out. So what we're going to do is slightly differently than what we've seen before. We are actually going to create a function called flatten. And that's because it needs to be called recursively. So we need to have like a named function that we can recursively call. If we just sort of do this sort of anonymous arrow function, there's no way, I don't think, to call itself. But flatten will take the same signature. So your accumulator and the current thing that you're iterating over. So we'll call it the item. So this is an item, this is an item, this is an item. And I'm just going to start reducing this. So we've got result equals folders.reduce. Our reducing function will be this flatten, and we will initialize it to an empty array. So let's finish out the flatten functionality. So item could be just an item, a string or a number, whatever, or it could be an array. So if this thing is an array, so array.isArray, what we need to do is basically recursively call itself so that it can flatten out all of its children. So what we're going to do is return the item so far plus item.reduce. So we've got like a reduce in a reduce where we are flattening. It's calling the flatten function, and our initial value is an empty array. Like that. I think that's right anyways. So if it's not an array, what we can do is just take the existing items and add in the item here. Like that. So if we run this, there we go. We've just flattened all of the folders out. So we've grabbed the first one. In that case, it's not an array, so it would have just spread out the existing items, which would be nothing because it's the first one, and it would have added the item. The second one, what it would have done is it would have received this array here. So it would have spread out the existing items, which is index, and then it would have spread out the result of reducing this array. And then, etc., it would have just kept going on and squishing things out, calling itself recursively. It is a little funky to get your head wrapped around this. We can console.log what the accumulator and the item looks like at each step. So if we were to call this, that does not help at all, eh? So the first time it's called, it's empty, and we've got index. The second time it's called, we've got our index in here, and we've got the item being this. But it just starts getting a little bit crazy because it's recursively calling itself. So let's just actually, you know what would be an easier way? Let's see if this works. what we are going to do is return the reduced version of that, except our initial value won't be an empty array, it will be the accumulator. Oh boy, if this works, it's going to be fantastic. Let's run this. Get rid of the console.log. Clear this out. Oh shoot. That's nice. All right, let me explain this again because I just simplified this, I think. So we are reducing the folders with this flatten function. We're starting out as an empty array. If the item that we're currently looking at happens to be an array, we are going to have to reduce things further. Using the flatten function again, except this time we're not starting out with an empty array. We're starting out with whatever we're currently at as we're accumulating the items in this array. If it's not an array, what we can do is just sort of, this looks very similar to when we were mapping. Spread out the existing items and add on the new item. That's cool. All right, the last thing we are going to do before we call this a day is we are going to try to create a simple version of reduce ourselves. And I say simple because the real version of reduce allows for some additional complexities. You don't have to pass an initial value. And if you don't pass an initial value, we'll use your first element of your array as the initial value. I don't want to deal with that for this example, so we'll just do a simple version. We are going to call this thing reduce. So like this. And just to prove that it's working, we will say reduce. What are we going to be reducing? We will pass in 1, 2, 3. Our callback function will take our accumulator and our number, and we're going to do a sum of it. So we'll say accumulator plus the number, and we will initialize this to 0. So here I am passing in our array as the first parameter. Here in the way we were using it before, reduce is a function of an array because it's been added to the prototype. In this case, I'm just doing a regular function where we're passing in the array that we want to reduce. We've got our callback and we've got our initial value. So what we can do is we can create a variable to store our accumulator. So accumulator, we will initialize it to initial, like that. Now we need to iterate over all of the items in the array. So we'll use a for loop for that. So let I equal 0, I is less than the array length, I plus plus. And what we want to do as we iterate over each element in the array is update our accumulator to whatever the callback returns. So we will call the callback, and callback expects to receive the accumulator, like that. The current element that we're iterating over, so this would be array at the index. And the actual callback function actually receives 2 additional arguments. It receives the current index that you're on, and I believe it receives the entire array. Let's just, we'll leave them there. They just aren't used at all. Cool, so it's going to loop through, calling the callback for each element, given the current accumulator, the current item, the index, and the entire array. And its result will replace whatever value accumulator had. So it's looping through and it's accumulating in the process. Once we get to the end, we will return the final value that it encounters. So if we run this, we get 6, which is exactly what we wanted. And we can even see if we add a console.log of the accumulator. Let's do it after, like that. We can see that it started out as 1, then it went to 3, and finally it got to 6, which was our last value. So that's a very simple, without any checking at all, that you actually did pass an array, you did pass a callback function, that your initial value is there, that the array is not. There's a lot of checking we didn't do, but this is a very simple way you can implement reduce yourself. And one way that we're not going to get into, but if anyone wants to try to submit a challenge, is how could you stop this loop to return the result, basically short circuit it. For example, if you're trying to find a matching element, if you find that element, there's no point in continuing on and iterating over the remaining elements. So it'd be cool if you could basically abort this reduce. I found the item I'm looking for. Here it is. Same with a few of them, like any. As soon as you find one thing that's true, there's no point in continuously looping over the rest of the items. You can basically abort and return true. It's all good. That would make it a lot more efficient. With all over 18, as soon as you find one that's false, you no longer have to keep iterating because it's already proven false. There's no point in going on. Same with find is what I'm talking about. As soon as we find the person, there's no point in continuing on. It would be cool to basically just say abort, here's the value, get out of there. I will commit to the source control my version of the short circuit. It will probably be up tomorrow if you're viewing this on Friday. Friday what day is it? The 24th of April. So if you look at this on the 25th on the source control, you should find my answer. Hope you enjoyed this. Hope you love reduce as much as I do. Have a good rest of the day. Take care. Bye.